Assalamualaikum warahmatullahi wabarakatuh, and today I would like to present about the experimentary fluid friction. We are from group 5 section 01, and my name is Muhammad Yusof bin Salahuddin, ID number MA18225. So I will start with the introduction. Fluid flow in a pipeline follow a certain governing equation. Viscosity in the resistance of fluid, which is liquid or gas, to change from a moving adjacent section relative to one other. Viscosity of a viscous flow, also known as Newtonian fluid, where when its fluid flow, viscosity come into effect and causing laminar or sometimes some other case turbulent flow. The aim of the experiment is to look at minor losses caused by the specialized pipe component and fitting on the pressure loss or head loss. Next is the experiment background. In hydraulic engineering, estimating the head loss sustained by a fluid as it runs through a pipeline is necessary requirement. It's important to figure out how much additional head is needed to double the rate of flow down an existing pipeline. Fluid mixing at the fitting, such as band or valve, as well as frictional resistance at the pipe wall, can cause a head loss. The frictional resistance to flow down a long straight pipe with a smooth side is investigated in the experiment described below. Next is the problem statement. The common term of minor losses that are usually used in many textbooks for head loss across fitting can sometimes be misleading, since the loss can be large fraction of the total loss in the pipe system. In fact, minor losses can be bigger than major friction loss in a pipe system with a multiple connection and valve. We need to investigate the pressure flow in the pipe, and then calculate the head loss and friction coefficient through the pipeline, and make sure the pipe join together in the place and open all the valve for the water able to flow through the pipe. Next is the objective and the scope of this experiment. The objective of the friction loss in pipe experiment are to understand and apply the basic knowledge of major losses in straight pipe, then to explain how the fluid friction phenomena in the pipe work in the term of mechanics. Next is the scope of the experiment. First is to set up the flow of water through the pipe with a different type of angle and condition. Then to take the reading of the pressure gauge by using the pressure sensor. And lastly, to calculate the fraction in the pipe and head loss.
Good morning, sir, and my fellow teammates. My name is Pang Jingyan with matrix number MA18221. I will continue with chapter 2 of this experiment, the theory part. So the pipes are generally assumed to be fully filled with the running fluid, where the liquids flow through the pipes are encountered with frictional resistance, resulting in loss of head or energy of liquids, which this can be further explained as viscous resistance or frictional resistance depending on the velocity of fluid flow. Afterward, the Darcy-Weisbach equation is commonly used for the computing of loss of head due to friction in pipes. It indicates the loss of energy head varies directly with the velocity head, pipe length, and inversely with pipe diameter. The constant of proportionally used in the Darcy-Weisbach equation, F, is called as friction factor, whereas the equation shown at the left side of the slide. Whereas, when the fluid passing through the fitting valve, gradual and sudden expansion or contractions and entrance and exit may affect the additional minor loss, which can be calculated by using the equation at the left side of the slide, where the HM indicates the head loss through the fitting or valve. V squared over 2G is the ratio of velocity head of the attached piping, and K is the loss coefficient of the fitting or valve.
Assalamualaikum and good day. My name is Shafi Ahmad. I will continue the presentation with the third chapter, which is the method and procedure in the friction losses in pipes experiment. Let's go through it one by one together. So the apparatus as shown in the slide consists of the following components. First is the pipe friction apparatus, which consists of straight pipe, 90-degree elbow, 90-degree bend, and 45-degree bend. Second is the personal computer with Daisy Lab, which is a data acquisition system. And third would be the National Instrument Equipment, as known as NI. And the fourth is the sensors, which consists of mass flow rate and strain sensor. Moving on into the procedure, the process begins with by turning the valve tab to the left. All the fluid friction device valve is open. When all the valves turn on, power supply and the pump can be switched on too. Second, the control valve is used and water volume adjustment is adjusted. Then the unused valve will be closed for the first experiment, that is the straight pipe. Third, following that, a pressure measurement inside the pipe was connected to the two pressurized sensors. Fourth, a flow rate can be recorded within the pipe by the flow rate indicator. The fifth step would be repetition steps 1 to 4 for various pipe types, including the 90-degree elbow, 90-degree, and 45-degree bending piping. And the last step would be all data are tabulated and volumetric flow head losses are recorded. I think that's a little bit from me. I'll pass the stage to my colleague in order to further this presentation. Thank you.
Assalamualaikum, my name is Muhammad Hakim Muhammad Isham, MA 18227, and today I'm going to present about Chapter 4, Result and Discussion for Lab 3, Friction Loss. For the experiment, we have been given data where the volumetric flow and measure head loss for straight pipe, elbow pipe 90 degree, bend pipe 90 degree, and 45 degree. Besides that, we are also given the length of pipe L equal at 100 meter mm, PVC pipe internal diameter 20 mm, PVC pipe thickness 1.5 mm, density of water rho equal to 1000 kg per meter cube, viscosity of water 1.01 times 10 power of negative 3 kg per meter. For the experiment 1, measure losses in the straight pipe. From the data given, you have calculate the flow speed, part friction coefficient, Reynolds numbers, and calculated head loss. From the result, we managed to get the graph as the calculated head loss increase, as the velocity is increased, the calculated head loss also increase. But for the part friction coefficient versus Reynolds number, as the Reynolds number is increased, the part friction will be decreased. For experiment 2, minor losses, elbow 90 degree, elbow pipe 90 degree, this is our result. We have calculated the flow speed, pipe friction coefficient, Reynolds number, calculated head loss, loss coefficient, and equivalent length. And this is the graph for the elbow pipe 90 degree. For the bend pipe 90 degree, we also calculate the flow speed, pipe friction coefficient, Reynolds number, calculated head loss, calculated loss coefficient, and equivalent length. This is the graph for the measured and calculated head loss versus velocity and loss coefficient for versus Reynolds number for bend pipe 90 degree. And lastly, bend pipe 45 degree. And this is our result. We calculate the flow speed, pipe friction coefficient, Reynolds number, calculated head loss, calculated loss coefficient, and equivalent length. And this is the graph from our result. And that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Izzat bin Ahmad Suhaimi. It can be concluded that each setup has different impact toward the result of the experiment. As for the straight pipe setup, the head loss decrease when the velocity increases, and the coefficient of friction decrease when the Reynolds number increases. As for the elbow pipe setup, the head loss decrease when the velocity increases, and when Reynolds number increases, the coefficient of friction decreases. As for 90-degree bend pipe setup, the head loss increase when the velocity decreases, and when the Reynolds number decreases, the coefficient of friction decreases. So for the 45-degree bend pipe setup, the head loss increase when the velocity increases, and when the Reynolds number increases, the coefficient of friction decreases. That's all from me. Thank you.